Okay, so this is the second part of operations with matrices, and we're going to talk about multiplying two matrices together. So when we multiply a matrix, we can only multiply the matrix depending on the dimensions of the first and the second. So let's say I have a 2 by 2 matrix, and I want to multiply it to another 2 by 2 matrix. If the inner dimensions match, then I can multiply them. So these have to be the same numbers. And our answer for the resultant matrix is going to be the outer dimensions. So here, when I multiply these two, I'm going to end up with a 2 by 2 matrix. For example, here I have a 3 by 2, and here I have a 2 by 2. And because the inner dimensions match, they're both 2's, then I can multiply them, and my answer is going to be a 3 by 2. So now let's find the product. When we find the product, notice that I took this 3, which represents the rows, and I took this 2, which represents the columns. So when I multiply them, I'm taking the row and I'm combining it to the column. So row of the first matrix, combine it to the column of the second matrix. Specifically like this. I want to match up -1, 3 with -3 and -4 like this. So we're going to do element 1 times element 1, which is -1 because it's row 1, column 1, times column 1 element that's in row 1 is -3. And then we're going to add it to, now I'm in row 1, column 2, 3, and then column 2 of the second matrix is -4. So I match them up based on their corresponding rows and columns through multiplication, and I want to add them. So that was the first element. Now I'm still on row 1, but now I want to look here at column 2. So I'm going to do the same thing. So that's going to be -1 times 2 plus 3 times 1, because I'm matching up the elements together. This is element 1 with 1, 2 with 2. We multiply them and then add them. And now that we're done with the first row, we're going to do the second row and the first column. So the pattern's going to continue. We're going to do 4 times -3 plus -2 times -4. So that was the first set of elements. Now we're moving on to column 2. So that's going to be 4 times 2 plus -2 times 1. Now that we're done with row 2, we move on to row 3, and we match it up with the columns. So that's going to be 5 times -3 plus 0 times -4. And then I have 5 times 2 plus 0 times 1. And now we're going to simplify it. And when we simplify it, this is what we get. And notice that I have my 3 by 2. So these are the properties that actually apply to matrix multiplication. We have our associative property, our distributive property, and we have our scalar multiplication. So when you're multiplying, the order does matter. So for instance, if I have, and I'm going to make up a matrix, 1, 2, 3, 1, 2, 3, 1, 2, 3, and so that's a 3 by 3. And I'm multiplying it to, let's say, a 3 by 2. 1, 2, 1, 2, 1, 2. This is a 3 by 2. We can multiply in this direction. Let's call this A and let's call this B. I can do A times B because the inner dimensions match. But I cannot do B times A. Take a look what happens when I do B times A. That means I have a 3 by 2 times a 3 by 3. the inner dimensions do not match. So therefore, I cannot multiply these. That's not possible. But I can do A times B, but I cannot do B times A. This one's undefined or not possible because of the dimensions of the matrices. This is possible. Okay. So this is something that looks very familiar. Our main diagonals ones, whenever we have zeros above, zeros below, that's called an identity matrix. Whenever we multiply, and the identity matrix must be a square matrix. Whenever we multiply a matrix by an identity matrix, take a look at what happens. I want you to try this, pause the video, and then check your answer. Alright, and if you multiplied it correctly, notice that you should end up with the same matrix. So whenever you multiply a matrix by an identity matrix, you end up with this matrix, or your original matrix. And the order doesn't matter in this direction.